Hello, we are the 2025 FIERF Forging Competition Team DesignWorks from Cleveland State University, and this is our journey into forging our own personal blacksmithing hammer. Our team consists of our team captain, Joshua Bailey, and members Adam Clark and Robert Herrick. All of us are mechanical engineering students. We decided to do this project because we wanted to learn what it takes to forge a hammer and what designs we might be able to do to make our hammer unique to ourselves. Here is our process that we did to make this possible. None of us had any previous knowledge as to what would make a good blacksmithing hammer, so we decided to ask those who actually use hammers for a living, blacksmiths. We made a questionnaire that we wanted to give the blacksmiths to get a good start on what makes a good hammer good and what things that they prefer or watch out for when making or picking a hammer. While asking blacksmiths around the area, we managed to get into contact with organizations that help spread our questionnaire further out. With these connections, we managed to get over 300 responses for our questions. We also made contact directly with some blacksmiths to talk more and ask further questions that we did not think of when we made our original questionnaire. From our survey, most of the responses said that they prefer a cross-peen hammer design, and so we went with that. Other factors, such as the desired weight and handle material, were also looked at for picking our design. We also looked into other factors, such as safety with using a hammer while forging and the physical tolls of using said hammer. Most of the results said that hammers are already designed to be pretty safe, but some things to be careful of is the possibility of the hammerhead flying off while being used, as well as that the vibrations from swinging the hammer can cause elbow and shoulder soreness and pain. We decided to go with a hammerhead that was around 2.5 pounds with a hickory handle that has a split design which is meant to help reduce vibrations, with the hammerhead being made with a 1045 steel that the competition required. With these parameters, we were able to calculate things such as the force generated, the deflection in the handle, as well as the stresses and strains that are occurring in the hammer. With this, we also used SolidWorks to run an FEA to look at what stresses are occurring in the handle when there is force being applied to the hammerhead. We also were able to use a program called Deform that is designed by Scientific Forming Technologies Corporation that we use to simulate the forging process and be able to simulate the grain flow of the hammer. We compared what the grain flow from Deform showed to what the actual grain flow was in our forged hammerheads. We had made a testing apparatus that we use to test the vibrations that occur in the handle when a testing hammer strikes a metal surface, which we measured using an accelerometer to see the change in distance after the hammer hits the bottom. With the help from our forging partner, Rose Ironworks, we were able to work with a blacksmith to forge the rough shape of our hammerhead. From working with Rose Ironworks, we were able to make 2 rough forged cross-peen hammerheads, and with the extra material left over, we created another punched hole so we can do testing on the 1045 steel. After being forged, the hammerheads were then machined by our group to the shape that we wanted. Then, with the help from Akron Heat Treating Company, the 2 hammerheads and our testing steel were heat treated to a Rockwell harness of 46 47 HRC at the surface, and from Cleveland State, a micro hardness tester was used to look at the hardness with a cut section going from the center to the surface of the steel with an average of about 285 Vickers with a 0.5 kilogram force being used. The leftover steel was then split into quarters, and using a solution of ferric chloride and distilled water was used to etch and show the grain flow of the steel. These etched pieces of steel show the grain flow that we have in the steel of our hammer, and we can compare it to what we have in the form to see how similar our results were. The hammerheads were also cleaned up and polished and had a final weight of 2.15 pounds, with a final touch from our captain Josh to laser etch the cheeks of the hammer to honor both Cleveland State University and the FIERF Forging Foundation. The hammerhead was attached to our 16-inch hickory handle with a slit that was soaked in linseed oil to help preserve and protect the wood, and a cork rubber gasket for added vibration dampening and to help better secure the hammer together. Finally, the hammerhead was then wedged with a wedge design that Adam made that acts as an expanding mandrel that can be tightened with a 1024 UNC hex bolt, so that if the hammerhead is feeling loose, the user is able to re-tighten with a 5/16 or 8mm socket, helping to ensure that the hammerhead has a less likelihood of loosening and flying off. With all of this, here is our finished blacksmithing hammer ready to be used in the forge. Thank you, and we hope you enjoy our hammer. Happy forging!